Lagay yan yung 0.32. Naka-store value, no? Dapat stored value yon 0.32 minus V1. Binigay na din sa problem. 0.106, 0.0774. 0.106, 0.0774 cubic meter over W2, that is W2 1.46 newtons. No, and then unit weight of water, naka-newtons, naka-cubic meter, therefore 9,810 newtons per cubic meter para mag-cancel yung units. No? So with that, ano po yung shrinkage limit value? Dapat mas maliit kay 0.32. This is 0.
Sir, negative po ang nakuha.
Negative? Bakit negative? 0.0774. Mas malaki to. Anong value negative?
Negative 191.85.
Laki naman. Negative 191. Bakit negative? Newtons.
Sir, 0.13 po.
1.46. How about the others? Paki-check nga.
0.13 po.
0.13. Bakit yung iba negative? Paki-check naman po. Wala lang akong calcu. $9.81. Mukha newtons kasi ito eh. Mali kaya to. I-ano nyo nga, i-divide nyo nga to. Ano naman? I-divide nyo nga yung 1.928 tsaka 0.106. 1.928, 0.106. Can you divide this one?
18.19 po.
18.19. Okay, mali ang unit. No. Usually kasi dapat ang unit weight naka-kilonewtons per cubic meter. No, kapag naka-kilonewtons per cubic meter, nasa 15 to 30 yung range value. No. So this should be kilonewtons, guys. Medyo mali lang siguro yung unit dyan. Kilonewtons yon. Kapag kilonewtons yon, hindi naman mababago yung initial water content natin dyan. So magka-cancel lang din yan. Kilonewtons, kilonewtons. Same as 0.32 tayo. No? So kung kilonewtons ito, dapat ito 9.81 kilonewtons per cubic meter. No? That is a typographical error siguro. No? Diyan pala ang malalaman nyo na sa value. Hindi yan magiging 18.19 Newton per cubic meter. So kapag Newton per cubic meter yan, naka 1,000 yan. Okay, so what is the value in this part?
0.13 po.
0.13. No? So, store nyo yung value niyan. Kapag na-store nyo na yan, that shrinkage limit is a value of water content. And that is the final water of the soil. Is omega GS. Ano yung omega final natin? That is 0.13. Anong GS natin? Pertaining to the solid, hindi yan nagbabago. So, same as 2.7. So, what is final void ratio? Kindly compute.
0.35.
0.35. How about the others?
Same lang po.
So that is our answer, no? So let's have another one. Pakibasa naman yung problem. Jaira.
A shrinkage limit test on a clay soil gave the following data. Compute the shrinkage limit, assuming that the total volume of dry soil cake is equal to its total volume at the shrinkage limit. What is the degree of shrinkage? Comment on the nature of soil. Mass of shrinkage dish and saturated soil is equal to 38.78 grams. Mass of shrinkage dish and oven dry soil is equal to 30.46 grams. Mass of shrinkage dish is equal to 10.65 grams. Volume of saturated soil in shrinkage dish is equals to 16.28 cubic centimeter. Total volume of oven dry soil cake is equal to 10 cubic centimeter.
Okay, so ano mga binigay sa problem, Ining? Ano kailangan mong i-compute? Ito sabi pa dyan, assuming that the total volume of dry soil cake is equal to its total volume at shrinkage limit. No? At hindi naman sinabi yan, yun yung talagang ina-assume natin. No? Dahil when oven drying, kailangan nating makompute yung shrinkage limit point. No? Yun yung what they call this one, yun yung ating goal talaga. Kaya lang hindi naman tayo makakatigil sa point na yan. Kaya ino-oven dry natin totally. No? So, what is the degree of shrinkage daw? Degree of shrinkage, ginawa na natin kanina yan. Ano yung degree of shrinkage formula, Jaira? DOS is equivalent to?
V1 minus V2 over V1 po.
Okay, that is correct. No? Kapag over V2 na yan, that is volumetric shrinkage na. No? So, may binigay na ba tayong V1, V2? So, ano ba yung una dito? Mass of shrinkage dish and saturated soil. So, mass of shrinkage dish and oven dry soil, and then mass of shrinkage dish. No, volume of saturated soil in shrinkage dish. Ito ay V1. Ito ay total volume oven dry soil cake, that is V2. No, kailangan lang natin determine si M1, the initial mass of the wet soil. And then yung M2, which is the final mass of the oven dried soil. How can you compute the value of M1? That is first mass parameter and the third mass parameter. No, kailangan nating i-minus yung mass ng shrinkage dish. para ma-compute natin yung saturated soil lang. And that saturated soil is the initial mass. So that is 38.78 minus 10.65. What is the value?
28.13.
28.13 grams. And then M2, the mass of dry soil, that is mass of shrinkage dish and oven dry soil minus mass of shrinkage dish, or 30.46 minus 10.65.
19.81.
19.81 grams. So you have M1, M2, V1, and V2. So you can now compute the degree of shrinkage. No, that is V1. Nasa na? 16.29 cubic centimeter minus V2, 10. Sakto. And then over V1, 16.29 cubic centimeter. Cancel dyan and then times 100%. So DOS is equivalent to
38.61.
38.61%.
61.
If that is 38.61, what is the nature of soil?
Very poor.
Oh, that is very poor also, no? Naalala ko si Catriona Gray. No, the life there is very poor. So, next one, meron pa ba? Parang wala na. Compute the shrinkage limit, SL. O, napakadali niyan, SL. Direct substitution na yan. That is M1 minus M2 over M2 minus V1 minus V2 over V2 or M2 multiplied by density of water. No? So direct substitution lang tayo. Ang M1 ay 28. Nasa ilalim. 28.13 minus 19.81 over 19.81 minus quantity 16.29 minus 10 over 19.81 times 1 gram per cc. So naka-decimal form lang yan. No, multiply nyo lang ng 100% para maging percentage form.
7.22%. 7.22% po.
7.22%. Na. So these are the requirements of this problem. O, diba? Napakadali lang, direct substitution palagi. No? Saan na yung yun? So let's have another one. Okay, this one. Pakibasa naman yung problem, Christian.
The following data shows the result of the liquid limit and plastic limit test. A liquid limit, the test number 1, number of flows equals 39. Test number 2, number of flows 23. Test number 3, number of flows equals 20. And test number 4, number of flows 13. The weight of the wet side plus container in test number 1 is 22.24 gram. In test number 2, 21.19 gram. In test number 3, 21.27 gram. In test 4, 26.12 gram. Weight of dry soil plus container. In test number 1, 19.44 gram. In 2, 18.78 gram. Then 18.75 and 22.10 gram. Weight of the container equals, in test number 1, 12.74 gram, 13.24 gram, 13.06 gram, 13.27 gram. D, plastic limit. The weight of the wet soil plus container in test number 1 equals 22.12 gram. In test number 2, 21.84 gram. The weight of dry soil plus container in test number 1, 20.42 gram. In test 2, 20.19 gram. Weight of container in test 1, 13.07 gram. In test 2, 13.18 gram. Letter C, natural water content. Weight of wet soil plus container in test 1 equals 17.53 gram. In test 2, 16.97 gram. Weight of dry soil plus container in test 1, 14.84 gram, 14.36 gram. And weight of the container in test 1, 7.84 gram, 7.5 gram. Compute the liquid limit, use the table shown, compute the plastic limit, compute the plasticity index, and compute the liquidity index, plasticity index, flow index, toughness index.
Okay, no? So, madami lang yung tests or tables na binigay, no? But then, when we say liquid limit, plastic limit, and then natural water content, they are values of moisture contents. No? So, ang goal lang natin dyan ay makompute yung water content out of these given parameters. So, discuss ko naman ito sa discussion natin, no? Kung paano i-compute yung water content. Anong sabi natin doon? That is mass of water over mass of solid. How can you compute the mass of water? That is the weight of wet soil plus container minus weight of dry soil plus container. Ay, naka-grams tayo. So, naka-mass parameters yan. Mass ng wet soil plus container minus mass ng dry soil plus container. No, over mass ng solid, that is mass ng dry soil plus container minus the mass of container. So, yan yung lang equation natin, no? So, you can now compute the water content in each trial. Okay, kindly compute using this equation. Or liquid limit test muna. This is first trial, siya ay 22.24 minus 19.44. Ang first trial ay 22.24 minus 19.44 over 19.44 minus 12.74.
0.42.
0.42. Store nyo kay A. Second trial, ano po yung water content?
(0.44)
0.44. Store the value as B. Third trial. Hindi ko na isusulat yung solution. Alam nyo na yan. Pa-follow lang yung formula. 21.27 minus 18.75 over
0.44.
44 ulit. Store the value as C. Fourth trial.
0.46 po.
46. Store the value as D. No? Ganon din yung plastic limit. No? Ko-compute yung water content. So, for the first trial, compute 22.12 minus 20.42 over 20.42 minus 13.07.
0.23.
23. And that is stored value as E. This one.
Zero point 24.
0.24. Store value as F. Next one. For the natural water content, same equation. Compute the water content.
0.38.
0.38. Store nyo kay X. Dami na.
0.38.
0.38 po.
0.38 din. 0.38 din ba?
Yes.
Okay, no. So, first one, the liquid limit test. Mapapansin dyan may number of blows. So, it will use Casagrande cup method. So, we'll just project 25. Nasaan yung pagitan? No, yung gagawin nyo. For plastic limit, wala namang method na ginamit. No? So, that is why, para makompute yung plastic limit, that is average value. Natural water content, hindi yan din ginagamitan ng test, no, or any method. Kumbaga ito ay averaging method din, no? So, get one first the plastic limit. Dahil mas madali siyang i-average. That is E plus F divided by 2. So, what is the plastic limit of the soil?
(0.23)
0.23 or 22 or 23 in percentage form.
23.33 po.
23.33%. I-store nyo kay E ulit para naka-store pa rin yung PL. And then determine the natural water content. Natural water content is the average also of the test. No, so that is X plus Y over 2. Dahil dalawa lang naman yung trial or trials natin, no? So average ng dalawang moisture content, that is
0.19.
38 then? Or
0.38 po.
this is 37 or 38 point something.
0.38 po.
In percentage form,
38.24 po.
38.24%. I-store nyo kay F. No, parang tayo round off. No, you have PL, you have the natural water content stored at E and F. No, balikan natin tong liquid limit test. No, for the liquid limit test, dapat naka-project yung 25. So, sulat lang natin ulit. If the number of blows is 39, its corresponding water content is, or in decimal form lang siya, 0.42, naka-stored value yan. And then, dito si 23, 0.44. And then 20.44, 13.46. 20.44, 13.46. No? So yung 25 nasa pagitan ng 23 at saka 39. So dyan natin siya ilalagay. No? So iproproject lang natin dyan, yun yung liquid limit. No? So ang gagamitin nyo lang ay yung nasa tabi ng 25. No? So ito yung ima-minus natin for the ratio and proportion. No? Yung dalawang tabi ni 25. So 39, 23. No? So that is by ratio proportion, 0.42 minus LL over 0.42 minus 0.44. Equivalent to naka-logarithmic scale ang number of blows. So logarithm of 39 over 25 over logarithm of 39 over 23. Pwede naka-minus if you want, no? Make sure lang na naka-log din yung isa. So, LL is equivalent to, dapat nasa pagitan ng 0.42 tsaka 0.44. Kindly solve. Naka-stored value si 0.42 ha, tsaka 0.44. Naka-stored kay A at tsaka B. Dahil 23 tsaka 39 yung ginamit. So what is liquid limit?
(0.43)
0.43. How about the others? Parehas lang or in percentage form?
43.23%.
How about the others po? Parehas lang po ba? Paki-confirm naman po.
.449 po ang nakuha ko.
449? Parang mali yung ining. Lagpas na siya kay 0.44. Dapat nasa pagitan lang ng 0.42 at saka 0.44. Kindly recompute. Ang 0.42 ay A. Ang 0.44 ay naka-store kay B. Maki-calculate naman po yung iba. Wag lang nakatungangan, no? Wag lang mag-antay ng sagot.
0.43 po.
43.23% din.
Yes po, sir.
43.44%.
Ano daw? 43 point?
44%.
Nako, hindi kayo pare-parehas.
43.23
po.
Ayun, 43.23 daw. Mas madami to. So, ito yung susundin natin, no? So, assume natin or store natin to kay X. No? So, tapos na tayo sa mga test. Ngayon, punta tayo kay requirement. Compute the liquid limit. So, na-compute na yung liquid limit. No? Compute the plastic limit. Na-compute nyo na. Compute the plasticity index. Pag na-compute nyo na yung LL at saka PL, mako-compute nyo na yung plasticity index. That is LL minus PL. So, that is 43.23 minus 23.33. Naka-stored X minus E. What is plasticity index?
19.90.
19.90%. No? And then, compute the liquidity index. Store natin to kay Y. Magamit. Liquidity index, dapat alam yung equation. That is omega minus PL over PI or LL minus PL. That is omega. Na-compute na natin yung moisture content. That is 38.24. 38.24 minus plastic limit. 23.33 over PI 19.90. No, ito ay naka-store kay F, ang PLI E. F minus E over Y. F minus E over Y. What is liquidity index?
0.75.
0.75. No? And then next one, compute the plasticity index. Tapos na yon. Compute the flow index, IF. So, flow index, IF, omega 1 minus omega 2 over logarithm of N2 over N1. No? Kaya lang ito, gagamitin natin yung extremities values. No? We are going to use 39 and 0.42 and 13 and 0.46. No? 0.42, 0.46. Yun ay naka-store kay A at saka D. No? 0.42 at saka 0.46. Naka-store kay A at saka D. So, 0.42, 39, 13. So, 0.42 minus 0.46 over logarithm of 13 over 39. So, what is flow index? Kindly compute.
0.078.
0.07
8 po, sir.
8. No? So, store nyo lang to. Store nyo kay A. If you want. Meron pa ba? Gamit naman na natin yung mga yon. And then, the last one is the compute toughness index. Toughness index TI, that is PI over IF. No? Ano ba yung plasticity index natin? That is 19.90. Naka-store kay Y. 19.90 over flow index 0.078. No, eto naka-percentage yung PI. Diba? Etong flow index, naka-decimal form yan. Dahil decimal form din to. No? So therefore, naka-percentage dapat yan. Times 100%. So what is toughness index? Kung naka-decimal o naka-percentage form na to, wag na kayong mag-multiply ng 100 doon. No? So what is toughness index?
2.54.
2.54. No? So these are the requirements for this given problem. So, basically, ko-compute lang natin yung mga moisture contents. No? Oh. Let's have another one. Okay, pakibasa naman yung problem. Kung hindi nababasa dito. John.
A saturated 100 cubic meter clay sample has a natural water content of 30%. It is found that the shrinkage limit occurs when the water content is 19%. The specific gravity of soil is 2.70. Compute the shrinkage ratio. Compute the volume of sample when the water content is 15%. Compute the mass of dry soil sample.
Okay, ano yung mga binigay sa problem natin, Utoy?
Water content po na 30%.
Okay, water content 30%. And then,
Tapos,
that water content has a corresponding volume, di ba? Now, when the water content is 30%, its volume is equivalent to
100 cubic meter per
cubic centimeter.
centimeter. And shrinkage limit, water content po na 19% nung nag-offer po ng
Okay.
shrinkage.
Okay, so water content din yan or that is shrinkage limit equivalent to 19%. And then binigay yung specific gravity ng solids. No? Anong tanong sa problem? Compute the shrinkage ratio. SR daw. Paano nyo makakompute yung shrinkage ratio? Can you compute the shrinkage ratio?
Ano po, yung M2 over dito, tapos density of water po.
Density ng water. Ito yung hinahanap. Do you have M2? Do you have V2? Ito initial, di ba? Initial conditions yung mga yan. No, so this is omega 1. Initial moisture content and this is initial volume.
Wala
Tama?
pong division.
So dyan ba sa mga binigay na yan, kunyari, sorry. Sa mga binigay na parameters na, ano yung mako-compute mo pang parameter? Kunyari, hindi nyo pa ma-analyze yung equation na gagamitin. So, make use of the given. So, out of that given parameters, ano yung parameter na mako-compute nyo? If you have shrinkage limit, specific gravity, ano yung mako-compute mo, John?
Yung DS over W1.
Ang tinatanong ko, anong mako-compute mo? Kapag meron kang shrinkage limit tsaka specific gravity ng solid. I'm not asking for the equation.
Yung ano po, specific gravity po.
Binigay nga specific
SL po.
gravity. Binigay nga rin yung SL. Ang
Shrinkage
tinatanong ko,
limit po.
binigay na Utoy.
Ha?
Binigay ang shrinkage limit, binigay ang specific gravity. Yan nakasulat naman dyan. Out of these two parameters, ano yung mako-compute nyo? Yes, that is SR. No? O anong equation yung gagamitin?
Yung sa specific gravity po na GS equals 1 over SR minus SL over 100 po.
Substitute, no? Ang GSI 2.70 equivalent to 1 over SR unknown, and then minus SL 19 over 100. So shift solve nyo na lang yan. You can now compute the shrinkage ratio.
$1.78 po.
Okay, 1.78. O, yan na. Store nyo yung value kay A. No, pag meron kayong shrinkage ratio, nadagdagan na. No, hindi na lang aapat yung binigay. Meron na kayong 5 parameters. Ngayon, how can you compute the value of... Ay, yun na pala. Shrinkage. Ayan, kuha na pala yung shrinkage ratio. Now, compute the compute the volume when the water content is, hindi pa pwedeng 15 yan. This should be 19%. No, malito, typographical. Compute the volume sample when the water content becomes 19%. Ang ibig sabihin lang nun, i-compute natin yung volume corresponding to this moisture content at shrinkage limit. Ano daw yung volume dyan? No? So, pwede natin sabihin ito yung omega 1, ito yung omega 2, ito yung V1, ito yung V2. Di ba? Ngayon, na-compute na natin yung shrinkage ratio. And shrinkage ratio, meron siyang relationship kay initial and final volume and then initial and final water content, di ba? Using yung isang equation niya. That shrinkage ratio is equivalent to V1 minus V2 over omega 1 minus omega 2. No, substituting, we have 1.78 equivalent to V1, 100 cubic centimeter minus V2, that is unknown, over V2, over omega 1, 30, ang omega 2 ay 19. So, ito ay 0.30 minus 0.19. So, what is the value of V2?
$83.59.
83.59, no? Which is a correct value naman siya, no? Dahil dapat yung V2 mas maliit kay 100. Dahil mas lumit yung water content dyan. No, same answers po ba sa iba?
Yes.
Okay, yes. So, store natin kay B. No, and the next one, compute the mass of dry soil sample. Ano ba yung mass of dry soil sample? Ano yan? Kung ito si V2, ano to? Ang ano ay?
M2.
Yes, that is correct, no? M2. Paano nyo makocompute yung M2? Anong parameter or equation gagamitin nyo? May SR kayo, may V2 kayo. Another equation for shrinkage ratio. No, that M2 over V2, or that SR is equivalent to M2 over V2 multiplied by density of water. So, direct substitution din, di ba? 1.78, ang M2 ay unknown. Ang V2 ay 83.59 multiplied by density of water, naka 1 gram per cubic centimeter. So, cancelled na. By cross multiplication, naka grams yung unit ng mass of dry soil, or M2. What is M2?
149.17.
0.17 grams. And these are the requirements in this given problem. Na? Questions? Are there any questions?
Wala pa naman po.
Wala naman po, sir.
So, 28 pa din. Ako. Excuse me. Okay, so kung walang question po, no, that ends the discussion for this topic, no? So,